Okay, guys, we're going to do the next part of our histology, which is connective tissue. Like the um, epithelial tissue, there's quite a bit of variety in here. So let's go through this. Connective tissues are one of the most widely distributed and the most abundant of the tissue types in the body. These are the things that hold us together. These guys, you don't find them outside the body. Now, if you recall, we said that the epithelial tissue was avascular. Connective tissue, on the other hand, has a great blood supply, with some exceptions. Cartilage, tendons, and ligaments, which is the reason why if you damage a tendon or a ligament or a cartilage, it takes forever for it to heal because there's no blood supply for the repair cells to get there. Cartilage, or excuse me, connective tissue is made up of a lot of different types of cells. There's not one cell type, with the exception again of cartilage. There you're going to see the chondrocytes. One of the main characteristics of connective tissue is you have a lot of stuff outside the cell, the extracellular matrix. These are going to be fibers and so forth, non-living things. Connective tissue comes from an embryonic tissue, one that develops in the baby prior to birth, called a mesenchyme. Okay, extracellular matrix itself has two components. One is the fibers. These are going to be things like collagen or elastic fibers or reticular, which are kind of web-like fibers. That's going to be one. The second one is going to be the ground substance. What is the ground substance? It could be a liquid. It could be something that's kind of gel-like. It could be something extraordinarily hard like bone. The fluid in space in between the cells, proteoglycans, proteins with sugars attached, and the cell adhesion proteins are part of the ground substance. The ground substance is going to be the medium that the nutrients from the blood vessels and the capillaries diffuse. We'll show you some pictures here in just a second. And here's a second. This is a type of loose connective tissue. This loose connective tissue is called irregular. Irregular. Okay, here are some cells. A lot of these cells are actually fibroblasts. They're special cells that make these protein fibers. If you look, you'll see those fibers, collagen and elastic and reticular. It's hard to see the reticular, very small right there. But that's the ground substance. The ground substance is everything outside the cells, guys. That's it. And in this, it's very loose and open. There's not a lot of cells. Remember how epithelial cells is just one cell right after another in these big sheets. Connective tissues are going to be mostly ground substance with few cells. Now this irregular is what forms that basement membrane we were talking about on epithelial cells. This is also going to be around our blood vessels and nerves, around the esophagus and the trachea. It's going to be an outer covering. This is also going to form some of that covering called the fascia between muscles. Mesentery is connective tissue that attaches the bowels to the back of the abdominal wall. Visceral layers of the pleura and the pericardium. If you remember, we were talking about you've got the parietal layer on the pericardial cavity, and this guy reflects back the visceral layer. So how do you tell this? If you were to see this on test, look for the empty space, guys. Look for the multiple fiber types, but look for the empty space. Adipose tissue, this is also a type of loose connective tissue. Although in this case, the cells are actually jammed together fairly well. Now, I know that this looks like simple squamous epithelium that's from the lungs, but it's not. How can I tell? Well, there's only one nucleus, and this is basically a bag of oil, triglycerides. These are where we store our extra calories. If I were you guys, I would take this and compare it to the one that we saw at the back of the epithelial PowerPoint, showing that, because they are easy to confuse, and a lot of students do that on the quiz and on the exams, and there's no sense for you missing that. You just need to spend a little bit of extra time. Where do you find adipose tissue? Subcutaneous fat beneath the skin. The breast, female breast, are mostly adipose tissue. On the surface of the heart is cushioning. In those mesenteries, around the bowels, around the eyes, and the kidneys have a padding of fat around them to protect them, to cushion them. Reticular tissue, this is the last type of loose connective tissue that we have. Reticular, you remember we said reticular fibers are net-like. Look and trace those fibers and you will see that they are very net-like. Okay? It's even easier to see down here because it's a lower magnification and you can see the pattern much better. So reticular is going to be fairly easy to tell as well. These are going to be in the lymph nodes, spleen, the thymus. They actually help to form kind of like a soft skeleton or bracing material. And there's some of this in the bone marrow as well. Okay, this is dense, regular connective tissue. What you see there are collagen fibers that are running parallel with each other, and you see very few fibroblast nuclei. And a lot of these sections, these guys will be wavy, but that's not a guarantee. How am I going to tell the difference between this and the smooth muscle? Well, when we get to the smooth muscles, I will tell you about that, guys, okay? Anyway, dense regular connective tissue. These guys are found in those tendons and ligaments, and this is something about these guys. They run like this. They are very tough when you pull them like that. However, if you pull them like this, perpendicular to the direction of fibers, they have no strength. All their strength is concentrated along the long axis of the tissue. Dense, irregular connective tissue. The fiber directions are not running in straight lines like this. They're running in every possible direction you can imagine. These guys are going to be the deeper part of the lower part of the skin. We'll talk about that when we get to the skin integumentary system. These guys are going to form capsules around organs like the liver, the spleen, and the kidneys because they are very strong. These guys form sheaths around cartilages and bones. Now, which direction do these guys have the most strength in? Every direction. That's why we use these, because they have fibers. Since they have fibers running in every direction, they have strength in every direction. Okay, guys, dense regular and dense irregular look nothing alike. And this is the third and last of our dense connective tissues. You could call it dense elastic connective tissue if you like, or just elastic. These guys are going to be, they look like crepe paper. If you've ever seen crepe paper, you actually see those elastic fibers like that. You can see them, and these guys that's why they will stretch. These guys are going to be in the walls of the large arteries and some of the medium ones, especially that looks like the aorta to me. They're going to be there in the vocal cords because they are also something that has to stretch. And in some of the ligaments of the vertebral column around your spine, the bones of the spine. Okay, guys, so now we go to the next type of connective tissue, which is cartilage. The tip of your nose is made of hyaline cartilage. The ends of the bones at your joints that move. If you've ever had fried chicken leg, the white stuff that you see on the end right there is hyaline cartilage. It's white, it's smooth, and it reduces friction a very significant amount. The rings around your trachea that hold it open, the larynx, costal cartilage. I don't know if you guys know, but the ribs attach in the back to the vertebrae, but when they come to the front, they don't actually directly attach to the breastbone. They actually attach to a piece of cartilage which attaches. Why is that? Well, because cartilage stretches a lot better than bone does. All of our skeletons started out 100% as hyaline cartilage, and then it changed to bone. And there's some animals that are still totally cartilage, such as sharks. Okay, now how am I going to tell this? Well, there are fibers in that cell matrix. That's in that ground substance, but you don't see them. They're not prominent. So a lot of times they will have these guys on a white background because of the stain they use. And in those instances, I always remember these as eyes in a snowbank. Whatever helps you. Those are the nuclei of the chondrocytes. These are the mature cells. The chondroblasts are the cells that are still making this ground substance. Well, they actually do the fibers and then some of the rest, proteoglycans and so forth. This that they're sitting in is like a little shallow bowl-like depression, and that's called a lacunae. You're going to see those again in the bone here in just a minute. Anyway, cartilage, hyaline cartilage. There are more than one kind of cartilage. There would be, wouldn't there? Elastic cartilage, that's not elastic tissue. How can I tell? Well, I've got these chondrocytes and these lacunae, right? How do I tell the difference between this and the hyaline cartilage? Look at all those fibers in there. These are things you're going to find on the epiglottis. Your external ear, the reason our ears don't break off when we hit something is because they've got elastic cartilage in them that allows it keeps them to keep their shape, but they are bendable. Eustachian tube that runs from the back of the nose to the middle of the ear is also this elastic cartilage. This is fairly easy to tell, and again, it looks like cartilage. Next is fibrocartilage. Now, this guy, it's harder to see. You can see some lacunae. Always look for lacunae. That's me, though. And These guys are going to have collagen fibers, and they're going to have a lot of them. So they don't look like hyaline cartilage. They don't look like fibrocartilage, or excuse me, elastic cartilage. What they do may be, if you try to zip through this, you may think this looks like dense regular. There's some similarities, but dense regular does not have cells sitting in lacunae. Where are you going to find this? The pubic symphysis, that's in the front. The hip bone joins together at the pubic symphysis between the disc in your back. Those slip discs everyone's talking about, they're made of fibrocartilage. Menisci, if you look at the top of the shin bone, the tibia, you'll find they've got cartilage pads like that, C-shaped. That's what your thigh sits on. Those are all fibrocartilage. Okay, guys, on to the next. Blood is super easy. Nothing in the whole body looks like this. This is what we have in the heart and in the blood vessels. What is the ground substance here? It's the fluid, the plasma. Basically, it's just water with some proteins. The cell types, you've got the red cells here that carry the oxygen. You've got the white cells that fight infections. And there's little bitty pieces of platelets. And you can see the white cells here. So this one should be a piece of cake for you guys. You should get this without any trouble. It is so easy. Spongy bone. Okay, you've got your bone, and the outermost part is compact bone, but on the inside you get all these struts that are going in all kinds of directions. Not at random. They do it according to how you use your body. Then you'll put struts in the direction that you get pressure. The middle layer of flat bones, the head of long bones, and the inside the shaft as well. There's the head. So hard to see, but these guys have got osteocytes sitting in lacunae. They sit in lacunae too. That one's going to be a tough one, guys. I'm trying not to give you that one. This one, compact bone, is absolutely a piece of cake. I mean, that looks like a tree that has been chopped down. Those look like growth rings, and as a matter of fact, they are growth rings. These guys, these little black dots that you see there are the osteocytes. They're sitting in lacunae right there. You mean that's not a cell? That's not a cell. That's actually a whole central canal. We'll get to that later. But that's these, as far as identifying these guys are so easy. I mean, seriously, you cannot miss them. Okay, what do you guys think about that one? Let's see. I see cells in a lacunae. I see fibers, but not all over the place. I would call that fibrocartilage, based on the density of the fibers right here. This guy, I see fibers, thick fibers, and thin fibers, and some cells, and a lot of empty space. Irregular connective tissue, loose connective tissue. What about this guy? He has to be elastic. dense or elastic dense connective tissue, however you want to say that. And in this guy, can't be anything else but the bone. All right, guys, that's it for the connective tissue. There's a lot in here, and you're going to have to spend a lot of time on this, but I think it'll be worth your effort because it is. You're definitely going to see this on quizzes and tests. All right, I'll talk to you in the next one.